Okay, let us let us start our second lecture in chemical kinetics. So this one is Arrhenius, the problems related to Arrhenius equation. So what is Arrhenius equation? K is equal to A e power minus EA by RT. So the equation appears to be simple, but more number of problems are asked from Arrhenius. So even in the last CSIR exam, that is in the June 2025, I saw 3 problems from Arrhenius equation. Okay, so in this video, I am going to solve 2 basic problems from Arrhenius equation. Let us move to solve the problems. Okay, so what is the first problem? The decomposition of hydrocarbon. Decomposition of hydrocarbon, any hydrocarbon that follows the equation K is equal to 4.5 into 10 to the power of 11 per second into e power minus 28,000 K by T. Calculate activation energy. So they didn't ask anything else, only activation energy. So it's very simple. You just write down the Arrhenius equation. What is Arrhenius equation? K is equal to A e power minus EA by RT. A by RT. Okay. So you just equate this equation with the problem. So we don't need any A. We need only activation energy. Therefore, you just equate the power alone. So therefore, otherwise you can equate the exponential functions on both sides. So that is e power minus EA by RT is equal to e power minus 28,000 A by T. Okay, so this is the exponential on both sides. So now equate the powers alone. So minus EA by RT is equal to minus 28,000 A by T. Okay, so therefore we can equate the values. So therefore, what is activation energy? Because the activation energy is therefore the activation energy is very lovely. EA by RT. So therefore you can simply strike out the temperature. It's not putting Y. Second, EA by T equal to minus 8,000 K by T. Okay, so you just cancel the T values. Temperature is, you can cancel the temperature. So our job is to calculate the activation energy. Therefore, activation energy is equal to minus 28,000 into K into R. So now you substitute the values for R. So what is R? 8.312. Substitute that values. 28,000 A into 8.314 joules per Kelvin per mole. So I just cancel this Kelvin into Kelvin. So if you multiply these two values, you can get so minus EA by RT. So we have to add this minus. So minus minus can be removed. It's also plus, it is also plus. So 28,000 can be written like this. 2.8 into 10 to the power of 4. 8.314 joules per joules per. What is the final answer? 232. 232.79 kilojoule per mole. Kilojoule per mole. Okay, so this is the answer. It's very simple. So it is asked in their exam from 4 or 5 years ago. I think it is 2019 or 18. Okay. So next question, the same type of problem. So what is it? The rate constant for the first order decomposition of hydrogen peroxide is given by the following equation. That is log K is equal to 14.34 minus 1.25 into 10 to the power of 4 Kelvin by T. Calculate activation energy for this. Okay. Calculate activation energy for this. So you can solve like this. So write down the equation log. Once again, it was log K is equal to 14.34 minus 1.25 into 10 to the power of 4 Kelvin by T. Okay. So you can equate this equation with the Arrhenius equation. What is Arrhenius equation? Ln K is equal to ln A minus EA by RT. A by RT. So the only problem is you convert this natural logarithm to conventional logarithm. Therefore, log K is equal to log A minus EA by 2.303 RT. So that's very important. Okay, so that's the only thing you have to do here. So next you equate these two values. EA by 2.303 RT is equal to, from the problem it is given us 1.25 into 10 to the power of 4 Kelvin by T. So we will strike out that temperature. Okay. Therefore, what is EA? Therefore, EA is equal to 2.303 into R into 1.25 to 10 to the power of 4 Kelvin. Okay. So if you simplify this, the value as 23 into 3.93 into 10 to the power of 4 joule per mole. What happens to this Kelvin? So when you substitute the value of R, so what is R? 2.303 into 8.4 joules per Kelvin per mole into 1.25 into 10 to the power of 4 Kelvin. Okay, so this Kelvin and the inverse Kelvin will cancel and we will be getting this value. And once again, you can rearrange the value as 239.3 into 10 to the power of 3 joule per mole or 239.3 kilojoule per mole. So this is the activation energy for this problem. So you can, so I have given one more problem. You can take it as a homework. So what is it? Rate constant of a reaction at 27 degrees Celsius is 5.4 into 10 to the power of 11 exponential of minus 50. So what's the question? What is activation energy? What is EA? So you take it as a homework. It is asked in GATE 2012. GATE 2012. So this question is asked in GATE 2000. Again, it's GATE wrong. GATE 2012 is asked. Now let me solve this. It won't be a problem. What is Arrhenius equation? K is equal to A e power minus EA by RT. So according to our problem, the K value is given as 5.4 into 10 to the power of 11 e power minus 50. You simply equate the values, that's all. So for minus EA by RT is equal to E of t is equal to minus 50. So minus minus got cancelled. Therefore, EA is equal to 50 into 8.314 joules per Kelvin per mole into temperature. You convert the 27 degrees Celsius into Kelvin. Therefore, 300 Kelvin. Okay. So inverse Kelvin and the Kelvin got cancelled and you find the answer in joules per mole. Okay, thank you for patient listening. I will meet you with some more problems. Thank you.